Good day, students. Now we're going to look at the solution to number 2 long answer question. This is in your chapter 5 sample quiz found in book 2 of your ma1026 booklets, and this is one is asking us to solve a logarithmic equation. Now the first one we did, we noticed we had logs on both sides. Okay, we had logs on both sides. So we had log on this side, the left-hand side of the equation, we call it LHS, left-hand side, and right-hand side. So we had the log of m equals the log of n. We had logs on both sides, so what did we do? When we got it down to a single log, we dropped the logs and let m equal n. So logs on both sides, drop the logs. But notice here, we don't have a log on the right-hand side. We just got a number. So what do we do when there's just logs on one side? Well, we have to go back to the definition of a log and what a logarithmic is. A logarithmic function is simply an exponential function written in a different manner. Using numbers, I will write one for you. So remember that means, of course, 2 to the power of 3 equals 8. So if we're using, say, log base b of some value equals, I call it e the exponent, then when we switch to exponential form, that becomes base raised to exponent equals that number or that value. Okay, so we're going to use this rule, but notice this rule applies when there's a single logarithm on this side over here. So we need it to make it a single log. Notice we have 2 logarithms here, so we have to make that a single logarithm. Okay, now anytime you bring logs together as one log, you check with this rule first. Do I have a coefficient in front of the log other than, say, 1? Therefore, before I move anything, I have to move the exponent, or right before I combine anything, I should say, we have to move the exponent up. So check for this rule first. Now I'm looking here. Now it doesn't apply here because look, both coefficients here are 1, aren't they? And other than 1 is what we're looking for. So then we're going to apply this rule here then. If we're adding under separate logs, okay, it means to do what? It means to multiply under a single logarithm. So we call that the product law of logs, right? So I'm going to do that. I'm going to apply that rule right away. These two will become a single log, okay? And that single log is going to be what? It's going to be the log base 2 of 4, I'll put the number in front, times x minus 2. Multiply those two equals 3. So I'll excuse me, I'll go ahead and do one more step here. I'll do the distributive property. You see it there, I hope, right? 4 times x and 4 times negative 2. So I'll do that at this stage. You don't have to do it in this stage. You could switch first, then do it. Makes no difference. Now, apply this rule up here. So now go back and look at this rule here, the definition. So switch out of log form into exponential form. So now we're switching. We're out of log form into exponential. So I always write the base first. Now what's the base? The base is 2. So we've used that number. 2 is done. See that? The next number we use, I put the exponent, right, on the base, and the exponent's this number over here, so that comes up on the base. 2 to the power 3 equals 4x minus 8. Now simplifying, of course, I get what? 2 cubed is 8 equals 4x subtract 8, and now I simply solve for x. So adding 8 to both sides, in other words, bringing the 8 over to this side, I get 8 plus 8 equals 4x, and 8 plus 8 is 16, and of course at that point 16 equals 4x. Alright, what do we do then? We divide each side by 4, and you can see the answer there now. X is equal to 4. Alright, so there's this solution for, and this is an example of a logarithm on one side with a number on the other. Okay, now the next video will solve the third and final one, which is another log equation. Hopefully that helps. Over and out.